you have to get this JAMB physics question. Now, the question of the day is, it says, the main purpose of a transformer in an AC radio set is to, okay? Now, what is a transformer? You should read. It's very complex. There would always be a question on transformers in your JAMB exam. Okay, so what is a transformer? What's the main purpose? Either to step up voltage or to step down voltage. Now, what does it do in an AC radio set? Okay, A says increase power to the radio. No, it does not. Okay, because all about voltage. B says convert energy from AC to DC. No, it doesn't do that. C says step down voltage. Correct. What it does is steps down the 240 voltage, that's Nigerian voltage, to 12 volts, that the electronic part of the circuitry of the radio can utilize. Okay, so that's what it does. It steps down voltage. All right, so you should get this JAMB physics question. It says in the diagram above, the pressure of gas is, now this is a simple question for you to do. If you have, this is under the topic pressure in liquids, okay? Where here it talks of, pressure of a gas. And this instrument here is a manometer, okay? Manometer, where you use to measure the pressure of a gas in a laboratory where water is used. Sometimes mercury is used. Now, in this case, mercury is used. So how do you measure? This is the gas being passed through this tube. Okay, so how do you now get the pressure of this gas? Okay, because that's what you're trying to measure. It's just simply the atmospheric pressure plus the height difference. So it's just 76 plus what? 10. And our answer here is option B. As simple as that. Simple. So you have to get it. All right. Everyone should get this JAMB physics question. Every one of you should get this. Okay, it's a bonus mark for you. Now look at the question. It says the motion of smoke particles from a chimney is typical of. So these are the options. I think the only thing that may confuse students is the word chimney, because it's not usually used. It's not frequently used in Nigeria. Okay, chimneys are always used in the West, in America, where the snow, they have to heat up the house and all that. But here, all through our weather is sunny, so we don't need all those, to keep ourselves warm. There's no snow and all. So I think that's the only word that might confuse people. What's a chimney? What's a chimney? Maybe it's something mechanical or something. No, what you should focus on is the word smoke. The motion of smoke particles. How do smoke particles move? They are random, irregular. So which particular type of motion should it fall? It should fall on what? Random. We have four types of motion. Remember, oscillatory, rotational, translation. You can't get this JAMB physics question. It says the energy associated with the emitted photon when a mercury atom changes from one state to another is 3.3 eV. Calculate the frequency of the photon. Here we use the formula energy of radiation, which is what E equal to what H what F. We're looking for F, which is the frequency, so make it subject to formula. It becomes F equal to E over H. Okay, so where E is this, we have to put in the value of E as what? 1.6. So we do what? 3.3 times what? 1.6 times 10 raised to the power negative 19, and we divide by H, which is what? 6. That's our Planck constant. 6 times 10 raised to the power negative 34. So this would cancel as 1. This would cancel as 2. I'm going to shift this 1 decimal place. This becomes 16. I add a negative 1 here. So 16 will cancel this 2 as 8. So we have 8 times. So what will be our power here? So this is negative. This becomes negative 19. So we have negative 20, negative 34. And that gives us a positive 14. So this will be raised to power 14. Our answer here is B. Now you can get this JAMB physics question. Okay, it says which of the following diagrams represent the magnetic field of two isolated unlike poles. So when we have the statement unlike poles, meaning it's a north and south. When you have the statement like poles, it means it's a north or south. Remember, unlike poles, what do? They attract. So you will likely have this kind of diagram for what? Unlike poles. But for like poles, they do what? They repel. All right, so you definitely have these two diagrams here. That's B and C for like poles. So it means this is wrong, this is wrong. Okay, because here you have a diagram, you have north and south. Okay, you can only get a north and north to have this representation of repel, the lines being repelled. But for it to attract, unlike poles to attract, the magnetic lines of force have to move from the north to the south. Okay, so our right answer is this and not this. Everyone should get this JAMB physics question. It says the thermoflask is designed to, okay, A says prevent heat loss or gain by conduction, convection, and radiation. Okay, B says prevent heat gain by conduction, the same thing. C says prevent heat loss by conduction, the same three things. And D says store hot tea and water. Please don't make the mistake of putting this. Please, please, that is not what a thermoflask is designed to do. Okay, the principle behind the thermoflask is to prevent heat loss or gain, not only to gain or to lose. Okay, it's both. It prevents heat loss or gain by conduction, convection, and radiation. And you should know the particular things that prevent this. Okay, for radiation, what prevents heat loss for radiation is the silver lining. For conduction, what prevents it is the insulating cork. And for convection, what prevents heat loss is what? You will get this JAMB physics question. Now, what does it say? It says the electrolyte in the nickel ion accumulator is, first of all, let's know what is the accumulator. The accumulator is a type of secondary cell. Okay, we have types of cells. Okay, we have primary cells, we have secondary cells. So this accumulator is a secondary cell. Now we have this nickel ion accumulator. Sometimes it is called the alkaline. Okay, it is called the alkaline what? Accumulator. All right, you also have the lead acid accumulator. Okay, so now in this particular accumulator, on the positive electrode you have nickel hydroxide, on the positive negative plate you have iron. Okay, and the electrolyte there is potassium hydroxide dissolved in water. So our answer here is option A. That is the electrolyte for the nickel ion accumulator. You can get this JAMB physics question. It says a certain manufacturer wishes to make an N-type semiconductor. N means negative type, okay? And it says, which materials would he select for doping? I hope you know what doping means. You remember? Okay, doping is just a method of making this semiconductor conduct electricity more. You get my point? So it's helps in reducing the resistivity of the semiconductor. That's silicon or germanium. Okay, those are types of semiconductor materials. All right, and there are two ways to introduce this impurity. Is either by donor impurities or acceptor impurities. Now, to create an N-type semiconductor, we do what? Donor impurities, and we impute atoms of 5 valency electrons. Okay, and you get that from the group 15 elements, which examples are arsenic and what? Antimony and also phosphorus. So our answer here is, look at this JAMB physics question. It says the correct unit of energy density is, so we have to use the fundamental units to try to get this correct unit. And what our fundamental units are? Mass, time, and our length. The formula for energy density is what? Energy over volume. And what is energy? Energy is force times distance. And what is volume? Volume is length times spread times what? Height. All are all in L. Okay, and our force here is what? M times what? A. That's mass times acceleration. And what is our mass? Our mass is our capital M. Okay, our acceleration is change in velocity over time. Change in velocity is L, and time is what? T minus square, because it's over time. Okay, so we have LT minus 2 times what? Our distance is in L, and all this is LL, so we have L cubed. So we cancel this L, we're left with one L here. So we finally have M L raised to negative 1 and T raised to negative 2. So M is what? Kilogram. This is length, and this is this. A radioactive element has half-life of 4 days. Remember what half-life is? That's the time taken for half of this element to decay. Okay, so now the fraction that has decayed in 16 days is, so half-life of 4 days. So that's every 4 days it's halves. Okay, there's a half decay. So we have to find the decay and what remains. Okay, so for the decay, let's assume that the total amount is x. So for the first half-life, so that will be x 1 over 2 of x, and which will give us x over 2. So that decay, and what remains will be x over 2. For the next half-life will be half of this x over 2, half of what remains, so that will be x over 4, and the remaining will be x over 4. The next one will be half of what remains, which will be x over 8, and the remaining will be what? X over 8. And the final half-life, which is the fourth half-life, will be what? Half of this, which will be x over 16, and the remaining will be x over 16. So this will be the remaining, while the total decay will be the summation of all this, and this will give us D. Battery connection that permits current to flow across a PN junction is called. Now, what's a PN junction? Let me just quickly draw it here. Okay, where you have P, you have your N, all right, and P are the what holes, and N are what negative, which are the electrons. Now you have your connection for the battery connection to permit current to flow. All right, you are going to have the negative charge of the battery here, and then the positive charge of the battery here, and the negative charge of the battery here. Okay, so electrons will flow. All right, it pushes electrons here, now crosses the depletion layer and to the poles, and current flows. Current will just flow. All right, so the only way this happens is in a forward bias system. All right, okay, in a forward bias system, it permits current to flow. So our answer here is what? Forward bias. Why a reverse bias does not? It prevents current flow. You will see that the terminals will switch. Okay, so our answer here is A. You can get this JAMB physics question. It says, which of the following diagrams represent correctly an NPN transistor? Okay, our right answer here is option D. All right, for an NPN transistor, where you have the base, the collector, the emitter. All right, the flow of current, the direction on the emitter is this way, downwards, okay, this way. All right, while the base is this way. Okay, so this is the right answer. So when you see an arrow on the collector, it is wrong. All right, this is a wrong circuit symbol. Okay, diagram. All right, where the arrow should be in here should be on the emitter. And for this is a PNP transistor. Okay, where on the emitter the current flow is this way. Okay, and on the base, current flow is also this way. Can you see that? All right, so our right option for this question for an NPN transistor is this symbol, where the current. You should get this JAMB physics question. It says, at low humidity in an environment, the human skin is usually, okay, you remember humidity? Okay, humidity is just the amount of water vapor, okay, in the atmosphere. Okay, water vapor in the atmosphere, in the air around you. That's what humidity is. Okay, so at low humidity is just like in Hamatan. Okay, Hamatan, where the air is dry. Now at low humidity, it means that there's low water vapor, very little amount of water vapor in the air. So everywhere will be dry, your throat will be dry, even your skin will be so dry, okay, and rough. So the right answer here is A. And let me tell you, at high humidity, when there's a lot of water vapor in the air and maybe it is quite very hot, all right, so when there's a lot of water vapor in the air and it is also hot, there's nothing to evaporate. How will the sweat on your skin be evaporated? It will be so damp. Okay, you will have a very damp skin. You will get this JAMB physics question. Okay, it says the process through which free electrons leave the surface of hot metals is known as. Now, A says electron emission. I know most people will just go for electron emission. No, 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 because you see free electrons. No, it's not. Okay, electron emission is a term that embodies all this. Okay, these are all types of electron emission. You have photon emission, okay, which is when photons are emitted when when photons are emitted when it travels from one energy level to another. Okay, photo emission is on light. Okay, when light hits a metal surface and electrons are emitted. Now, thermionic emission is when electrons escape the surface of a hot metal. All right, so our right option here is D. Okay, thermionic. You can get this JAMB physics question, okay? It says an electric heater with PD means potential difference, okay? That's voltage of 240 volts connected across its terminals, has a total resistance of 960 ohms, okay? That's resistance. Find the power rating of the heater. Remember the formula for power? I hope you remember. It is P equal to V squared over R. This is when we have V and R, or sometimes when you don't have, V, it is P equal to what? I square R. I hope you remember that's current and R. Okay, that's current and resistance. Now, we do here we have voltage and we have resistance. Okay, so we have 240 squared, that's 240 times 240 over our R, which is 960. So let's cancel. I'll cancel this, cancel this. 12 will go here 8 times, 12 will go here 2 times, 2 here 1, 2 here 4, and 4 will go in 240, that's 60 times. Our answer is what? A, 60 watts. Now look at this JAMB physics question. It says an engine of a car of power 80 kilowatts. Okay, kilo means 1000, so that's 80 times 1000 watts. Okay, so may moves on a rough surface with a velocity of 32 meters per second. The force required to bring it to rest is, remember, power is what work done over time. And what is work? Work is what? Force times what? Distance. And this is over time. And remember, d over t is what? Velocity. So finally we have F times velocity. So power is F times velocity. So we're looking for force. So force will be equal to P over V. And remember, our P is what? 80. So that would be 80 kilowatts. That's 80 times 1000. Okay, over 32. Our velocity, which is 32. Okay, so here we can do 8 will go here 4 times. 8 will go here 10 times. 2 will go here 2 times. 2 will go here 5 times, and 2 will go in this 1500 times. And when you do 5 times this, we get 2500. And our right option here is option. You will get this JAMB physics question. It says the capacitance of a parallel plate capacitor when in air is 3 microfarad and in the presence of a dielectric material 6 microfarad. Now, the dielectric constant is, remember, it is either it's called dielectric constant or it's called relative permittivity. Okay, and the symbol is this, and the formula is, your relative, the permittivity of the material, which is this, over the permittivity of free space, that is in air. Okay, it is either also equal to the capacitance in the presence of the dielectric material, okay, over the capacitance in air. All right, and from here, what we are given in terms of capacitance, okay, so the capacitance in the presence of dielectric material is 6, and that in air is what? 3. So you just divide this, and our answer is what? 2. And our right option here is option A. You can see it's this simple, so don't be scared of this. This JAMB physics question says if the relative density of gold is 19.2, the volume of 2.4 kg of gold is, now remember, what is the density formula? It is what? Mass over volume. So our volume will be equal to what? Mass over density. And remember now that density is not given to us, it is a relative density. And relative density, what is relative density? Is the density of substance over density of water, which we are given. So from here, our density will be relative density times density of water. So from here, volume will be equal to what? 2.4 over density, which is what? 19.2 times 10 raised to the power 3. Now I will shift this here, so I have 24 and 192, and 24 in 192 go 8 times, so I have 1 here. 1 divided by 8 is 0.125. Then I'll bring this up, which will become 10 raised to the power negative 3. So from here, I will shift here, this will become negative 4. So our final answer is what? D, 1.25 times 10 raised to the power negative 4 meter. Now, you can get this JAMB physics question. It says, in an experiment to determine terminal velocity, as the pressure increases the viscosity of a liquid, what happens? Okay, so there's an experiment where a ball bearing is dropped into a viscous liquid, such as engine oil. Okay, we notice that some forces act on it. Okay, where we have the weight, we have what we call viscous force, and we also have what? Upthrust. Okay, so it reaches a particular point, all right, where the ball doesn't accelerate as much again. Okay, so it begins to move on a uniform speed, and that point happens when the viscous force, okay, equates the what? Terminal velocity. All right, so there you have a uniform speed, so the speed remains what? Constant. So our right option here is B. Okay, it remains constant at that particular terminal velocity. As now you can get this JAMB physics question. It says one of the properties of gamma rays is that they are, A says neutral, B says negatively charged, C says massive, D says positively charged. Okay, now if you look at this option, you can quickly eliminate the odd one out, and the odd one out is this massive. All right, when you're talking about gamma rays, it is not about being quantity, it's not mass, it is about wavelength. Okay, that's wavelength, and it's about frequency. All right, when you're talking about rays, that's waves. Okay, so, and also their charge. All right, so this is absolutely off of it. So for gamma rays, one of the properties is that it is what's neutral. It is electrically neutral, so it can be detected by either electric waves or electric fields or magnetic fields. So our answer here is A question. Now it says non-luminous objects can be seen because they, A says are near, B says reflect light, C says emit light, D says are polished. So most students don't really know what is luminous or non-luminous. Are you with me? So, but you have to know the difference. Now, first of all, luminous objects that are luminous are those objects that produce their own light, like the sun, like fireflies, like the electric bulb. Okay, while non-luminous objects, they don't produce their light. They're just like a book, things that don't produce their own light. So the only way you can see them is if other sources of light bounce on them and reflect back into our eyes. Just like when you are in a dark room, okay, when you put on the light, that's only when you see other objects because the source of light are reflected back to your eyes. So the right answer here is B. You only see them when they reflect light. Okay, let's look at this JAMB physics question. It says the number of holes in an intrinsic semiconductor is, okay, so first of all, you need to know what intrinsic semiconductor, what does it mean? All right, when it says intrinsic, all right, an intrinsic semiconductor, it means that the electrical properties of this semiconductor is dependent on the material itself and not to any external factors. If you want a semiconductor to conduct more electricity, during fabrication of that semiconductor, they do what we call doping. Doping is you introduce impurities into the semiconductor so it conducts electricity more. Okay, so that particular type of semiconductor is called extrinsic semiconductor, in case you see that in your exam. But for intrinsic, okay, it's dependent on the semiconductor itself in its natural state, the electrical properties. So in this case, the number of holes will be equal to the number of what? Free electrons. In this case of now, let's look at this JAMB physics question. It says the reading of the micrometer screw gauge above is, now this is our main scale, this is the vernier scale. Okay, so from here, we now try to, this is 3, so this is 3.5, this is 4, 4.5, 5, 5.5, 6, 6.5. So the last marker here will be the value of the main scale, which is what? 6.5. So we have 6.5 here. Now let's go to the vernier scale. Where this line touches the value on the vernier scale, that would be the value of our vernier scale. So from here, this is 45. The next line is 46. Now 47. You can see 47 touches here. So this is 47. So you have to divide this by 100. Okay, always divide by 100. You're going to get 0.747. Then you add this to your 6.5 and we get 6.97. Our right option here is option B. This JAMB physics question says, what is the reading of the vernier caliper shown above? So here, this is the main scale. Now this is the vernier scale. So we have to look for the value for the main scale and then add to the value for the vernier scale. Okay, so how are we going to do this? Now look at the main scale. We have 1 centimeter here. Here is 1.1. Here is 1.2. Here is 1.3. So we stop here. Now you look at the vernier scale. This is where it stops. So the value immediately before, okay, where this vernier scale starts, that will be the value for our main scale, which is what? 1.3. So we put 1.3 plus, that's in centimeter. Now, to get the value of our vernier scale, we have to look for a point of coincidence where the marking of the main scale coincides with the marking of the vernier scale, and it is here. Let us count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and 9 divided by 100, which is 0.09. And when you add this, you get what? 1.39 centimeter. Hello, let's look at this JAMB physics question. It says the external and internal diameters of the tube are measured as this and as this. So that's 32 millimeter plus or minus 2 error. That's 21 millimeter plus or minus 1 error respectively. That's for the external and internal diameters of the tube. Now determine the percentage error in the thickness of the tube. Just use this simple formula. Percentage error is equal to what? The error, all right, over the actual value, okay, times 100%. Okay, that's what you use. So what is the error? All you need to do, just subtract these two numbers, all right, the error, that will be 2 minus 1. Then the actual values, just, do the subtraction of this. That's 32 minus 21, then times 100%. So you have here 1 over 11 times 100%, and it will give you 9%. Our answer is what? C. So we have a JAMB physics question here, and it says what? It says pressure, you have this, you have torque, it has this, you have current, you have power here. It says which of the above are the correct SI units of the quantities indicated. So these are the quantities and these are the SI units. So we have to confirm which of them is correct. Now look at pressure. Remember, what is pressure? Pressure is what? Force over what area. All right, and which is what? Newton over meter square. So it should be Newton meter per meter square. It shouldn't be this. There should be a negative. So this is wrong. Now, what is torque? Torque is what? Force times the perpendicular distance. Okay, so which is N times M. So this is correct. Current is what? Ampere, correct. Power is what? Is work over what? Time. And this is joules over second. So joules per second. So this is correct. So the correct SI units are this and this. And our right option here is option C. I. Now, let's look at this JAMB physics question. It says, the diagram above shows the velocity time graph representing the motion of a car. Find the total distance covered during the acceleration and retardation periods of the motion. Okay, now, people, you will just quickly insinuate that it is a total distance. And then you apply the formula for a trapezium, and finally you get either D, okay, or sometimes you get C. Okay, but look at it. It says the total distance covered during acceleration and retardation period. So where is the acceleration period? This. Here, from here to here is the acceleration. Why from here to here is what? Retardation. So you can see this covers like a triangle. This also covers like a triangle. So we have to find the area of this triangle, then add it up. Okay? So how do we do this now? Let us find the area of this triangle, which is half base times height. Remember, half base times height is the area of the triangle. Now, so where's our base? Our base is from here to here. So from here, this is 0, this is 10. So our base is 10. And what is our height? Look at our height. This is 10. So our height is 10. So this will be half times 10 times 10. Okay, and we'll cancel. This is 5. 5 times this will give us what? 50. So let us look for the other one. So we add it up. Okay, now this is the second triangle for retardation. All right, and we still use half base times height, area of a triangle. Now what is the base here? The base is, if you can see, this line stops here, so it's like in the middle of 40 and 50. So this will be 45. So the distance from 40 to this 45 is 5. Okay, and the height still remains the same, which is what? From here to here, which is what? 10. So we have half times our base, which is 5, times our height, 10. 2 would cancel this 5 here to give 10 here to give us 5. 5 times 5 is what? 25, right? So we add to 25. So 50 plus 25 gives us what? 75 meters. So our answer here is A. Don't be quick. I run um, brainstorming sessions on our paid group and also on the free Telegram group. You can join the free Telegram group. The link is in my profile bio, okay? And so you can join that Telegram group. I do free brainstorming session on it, okay, just to support you. But on the paid group, we do brainstorming session, we do online classes. That's where the online classes are, and it's always active Monday to Saturday. Okay, so you can join that. Is 3,000 naira. So I dropped this question, and a lot of people just made mistakes by just quickly going to find the area of this trapezium here. No, 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 no. Look at the question critically. It says during acceleration and retardation. So it's all about not rushing, but looking at the key points of a question, especially physics, understanding it before you start applying your formulas. All right. So our answer here is what? A. Okay. So don't forget to get the DTW JAMB CBT app to practice more. After you finish practicing, there are correct solutions there. If you don't get it right, you see the correct solutions. All right. Take care and see you in our next video. Don't forget, you are destined to win, and Jesus is coming soon. Give your life to Christ.